Hi, I'm Jamie Smith,
And I'm Celeste Funger.
and we're doing a limits problem, number 8. So the question is the limit as x goes to infinity of root x squared plus 2x minus x. So the first thing you need to do is you need to multiply by a conjugate. So you multiply by root x squared plus 2x plus x all over, or root x squared plus 2x plus x. And that is your conjugate right there. And so you multiply by the conjugate, and then you get limit as x goes to infinity, x squared plus 2x minus x squared all over root x squared plus 2x plus x.
So after you simplify this, you're going to end up with 2x over root x squared plus 2x plus x. And remember to put your limit sign in front of this problem. I didn't do that because I got a little bit lazy. But remember that until you plug in your point, or plug it in to get numbers, like right here, you can't leave out the limit sign in front of it. Next, you're going to divide by the x with the largest exponent, and in this case it's x squared. So you're going to divide every single term by x squared. However, don't forget it's the square root of x squared. So for this one, you're going to divide it by the square root of x squared, and I know that seems kind of difficult, but just remember that if it's in the square root, then you can just put x squared under it and keep it that way. X squared, the square root of x squared is x, and that's why I divided all the other ones by x outside of the square root, because if you kind of work that out, you'll see why we did that. Next, after you've done this, you're going to get 2 over the square root of 1 plus 2 over x, all plus 1. And you're going to plug infinity into x. And if you do that, 2 over infinity is basically going to get you 0. So you're going to have 0 plus 1 equals 1. So the square root of 1 is 1. Plus 1 is 2, and you're going to get 2 over 2, which equals 1.
And the most important thing is to remember that to follow the steps, so make sure to multiply by a conjugate. Look for that in the beginning of the problem if you're going to do that. And then when you get to a certain point where it's been simplified enough, then you're going to divide by the highest exponent in your denominator, and you're going to divide the entire equation by that, and that'll help you get your limit as x approaches infinity or negative infinity. And that's how you do this problem.